Today we are going to introduce to you the first AC machine, which is the transformer. Let's take a look at the structure of the transformer. This time we are going to introduce to you the entry brick into the AC machine. That is, all the principles of the transformer will be the same with the induction motor, synchronous generators, and synchronous motors. The transformer is the only immovable device in electrical machinery. It was Tesla's weapon to defeat Edison. Initially, Tesla used the transformer to convert the alternating current generated by the waterfall into a very high voltage. The voltage is then transmitted to the destination through long-distance transmission, and then another transformer is used to reduce the voltage. In this way, high energy can be transmitted to a distant place. Let's take a look at how the transformers are combined. The first thing you will see is a plastic shell. This shell is where we use to wind the coil. We put it on the machine and then use the enameled wire to wind it with the machine. Then we can wind the enameled wire around it. Assume it is a coil on the primary side of the step-up transformer. It will be thicker and have fewer turns. We just need to have this concept first. After the coil is wound, we will pull the two ends of the coil up. This is the wire outlet through which power will transfer as a step-up transformer. The coil on the secondary side will be thinner and have more turns. Here I use a very obvious comparison for you to see. You should be able to see the difference between them. In order to enhance the magnetic permeability effect, we will use silicon steel sheets and insert them into the center of the coil one by one in an overlapping manner. Here I use different colors to let you clearly see how they are overlapping. This is because the magnetic permeability of iron is thousands of times greater than that of air, and the addition of silicon can make the magnetic conductivity better. The main purpose of using steel sheets is to eliminate eddy currents and reduce power losses. When stacked layer by layer, the iron core you see most often will be formed. The heaviest part of the entire transformer is here, so we must reinforce it and then use metal clamps to fix the transformer. Because the iron core is made up of pieces, it must be clamped, otherwise, it will fall apart easily. We will use screws to lock it. What you see here are the screws, sleeves, and nuts. We will lock them all in order and finally form a transformer. After this simple introduction, we should be able to have a basic understanding of the structure of the transformer. However, the structure of the transformer is very diverse. What we see is just a typical example. Their basic logic is the same, and their methods are to make the current pass through the coil to generate a magnetic field, which then passes through the coil on the secondary side and converts it into current. This is the basic structure of the transformer. We will introduce it to you in more detail later.